Hey everyone, my name is Wabi, and welcome to the channel. Here, we uncover the mysteries of space and the hidden stories behind the stars. If you're curious about the universe and love learning fascinating space facts, you're in the right place. Today, we're answering a simple but magical question: why do stars twinkle at night? Let's get started. Of all the sights that connect us to the cosmos, few are as enchanting as the night sky. For as long as we've been human, we've looked up into that velvet darkness and seen a canvas of glittering lights. We've written poems about them, navigated oceans by them, and made wishes upon them. And at the heart of this celestial show is a simple, captivating phenomenon: the twinkle. It's so familiar, it's woven into our first lullabies and our biggest questions about the universe. We see it, we accept it, we sing about it. But what if the twinkle is a lie? Before we reveal the secret behind the twinkle, hit that subscribe button and join me on this cosmic journey, because here, every star has a story, and we're uncovering them one by one. You've probably sung Twinkle, Twinkle, Little Star at some point in your life. We all have. But what if I told you that stars don't twinkle at all? That beautiful shimmer is actually a massive optical illusion, a cosmic magic trick that happens in the very last fraction of the light's epic journey to your eye. The star itself, light years away, is a steady, constant, and wavering beacon. So if the star isn't twinkling, what is? Stick around, because by the end of this video, you'll never look at the night sky the same way again. Section 1. The quick answer and the grand deception. Alright, let's not keep you in suspense. The simple answer is this: it's not the star, it's our atmosphere. That shimmering, flickering we call twinkling is a distortion that happens right here at home, in the ocean of air that surrounds our planet. If you were an astronaut floating in the vacuum of space, that same star would be a perfectly stable and wavering point of light. Science calls this astronomical scintillation, a fancy name for what's really just turbulence in the air bending starlight. Think about it: the light from Sirius, the brightest star in the night sky, travels for over 8.5 years across 50 trillion miles of empty space completely steady. And yet, in the final 100 kilometers of its journey right here, in our atmosphere, it gets bent, buffeted, and made to dance. The twinkle is the story of that final, chaotic moment. And to really understand it, we need to follow light's journey into our atmosphere. Section 2. The journey of light, the tale of refraction. To understand why our atmosphere messes with starlight, we first need to talk about refraction, the bending of light as it moves between different materials. You've seen this before. Drop a straw in a glass of water, it looks bent or broken where it enters the water. That's refraction. Now, apply this to our atmosphere. Earth's air isn't a calm, uniform blanket. It's a chaotic, layered system: warm air, cold air, high pressure, low pressure, all stacked like an unruly onion. Each layer has a slightly different density, so as starlight enters, it bends again and again. If our atmosphere were perfectly still, that bending would be smooth and predictable. But it isn't. It's turbulent. It's wild. So instead of a smooth curve, starlight zigzags through countless tiny pockets of air, bending this way and that hundreds of times per second. From your eye's perspective, the star's brightness seems to flash and flicker. That's twinkling. A great way to picture it: imagine lying at the bottom of a swimming pool and looking up at sunlight shimmering on the surface. That dance of light. That's exactly what happens when you look up at a star through Earth's atmosphere. Section 3. A closer look at the twinkle. Now that we know the basics, let's zoom in on the details. Twinkling is more than just flickering. Its brightness, position, and even color. Position: stars appear to jiggle slightly in the sky because their light is bent randomly. For astronomers, this blurs telescope images. A night with calm air is called good seeing, turbulent air, bad seeing, intensity. This is the classic bright dim twinkling we all notice with the naked eye. Color: sometimes bright stars, especially low on the horizon, flash red, blue, or green. That's because the atmosphere acts like a messy prism, bending different colors of light by slightly different amounts. Sirius is famous for this rainbow twinkling when it's near the horizon. And here's a key fact: stars directly overhead twinkle the least. Stars near the horizon twinkle the most, because their light passes through more atmosphere to reach you. Fun tip: next time you're stargazing, test this out. You'll see planets steady and calm, while horizon stars shimmer like diamonds on water. Section 4. The crucial contrast: why planets don't twinkle. Here's where things get interesting. If stars twinkle, why don't planets? The answer: angular size. Stars are so far away they're just single points of light. One thin beam of light is easy for the atmosphere to push around. Planets, however, are much closer. Even though they look like dots to our eyes, they're actually tiny disks, extended sources. Each point on that disk sends its own beam of light. And while turbulence bends each one, they all average out. So, instead of flickering, planets shine steadily. Think of a single bulb a mile away and the wind it flickers. Now imagine a giant billboard of thousands of bulbs. Each one flickers, but together, the billboard glows steadily. That's the difference between a star and a planet. This simple trick of twinkle equals star, steady equals planet, has been used for centuries to tell the two apart. Next time you're outside, try it yourself. Section 5. The Astronomer's Curse and the Solutions for us stargazers. Twinkling is beautiful. But for astronomers, it's a nightmare. The same turbulence that creates twinkling makes images blurry and unstable. That's why telescopes on Earth, no matter how powerful, struggle without help. For centuries, astronomers built observatories on high mountaintops, where the air is calmer and thinner. But eventually, they invented something incredible: adaptive optics. Here's how it works: a laser creates an artificial star in the sky. Sensors measure how turbulence distorts its light. A computer calculates the corrections needed. A deformable mirror reshapes itself thousands of times per second to cancel the distortions. The result? Stars that looked like blurry blobs suddenly snap into crystal clear points. And of course, there's the ultimate solution: just leave the atmosphere behind. That's why we launched telescopes like Hubble and James Webb floating above Earth's air, where stars shine steady, sharp, and perfect. By the way, if you're loving how science and technology come together to solve nature's mysteries, make sure you subscribe right now. That way, you won't miss our next journey into the cosmos. The next time you're under a clear sky, take a moment to notice the difference. The flickering, dancing stars, those are suns trillions of miles away, distorted by our living, breathing atmosphere. The calm, steady points, those are our planetary neighbors, just a few light minutes from Earth. Now, you don't just see twinkling lights. You see physics in action. You see the difference between stars and planets. The twinkle of a star is where the immense scale of the cosmos meets the delicate chaos of our world. It's a beautiful illusion, a challenge for science, and a poetic reminder of how connected we are to the universe. If you enjoyed uncovering the truth behind the twinkle, give this video a like. It really helps more curious minds find us. And if you want to keep exploring space with me, don't forget to subscribe and hit the bell. Together, we'll turn the night sky into a storybook of cosmic wonders.